Continue looking at methods of approximation. And just in preparation for tomorrow's quiz, I just wanted you to work through this first page and kind of gain that term recognition. What does RRAM, MRAM, LRAM stand for? What does that acronym mean? Okay. And then there's a question after that asking you about approximation methods and which ones should be used. Tomorrow's quiz on Blackboard will be for section 5.1. You won't have a calculator, but I'm going to ask you to do an approximation method. So the numbers will be, pretty straightforward. The numbers will be integers, values, and stuff like that. So, so that you shouldn't need a calculator. So take a minute or two and at your table get this first page answered. And then today's focus is really applying these methods to practical applications. And we'll introduce those practical applications after you get that set up.
RRAM minus left RAM. No.
You said take left RAM plus RRAM minus left RAM.
In parentheses. So RRAM minus left RAM. Whatever that is. And then add it back to left RAM. I feel like
I'm trying to look more about
I'm sorry.
So we are literally filling in what those terms mean so that each word, what those terms mean, each word, what those terms mean. Okay.
Yeah.
This is a summary. Okay. That extends everything.
oh, I thought this was.
Check it. Okay, check it. I was kind of estimating. But I have extended everything. I'm just sooner than later. Yeah.
But I can use a unit for if that was assigned to 7%.
Yeah, I don't start with that. Yeah, I'm sorry. I'm just going to get rid of a couple of things taken care of. Just sooner than later. Okay.
Curiosity. If you try to
We only get 7%.
Oh.
Okay.
Okay. I thought
Well, no, because at this point, I just want you to get some basic understanding.
it's at like something.
And you want to get to 100 so that you have just a really good chance of getting something higher than 1 or 2.
If you took the difference between RRAM and then added it back to left RAM, would you get the perfect answer?
Get our
You wouldn't get necessarily get a perfect answer unless this curve was
Okay.
unless we
Just
did
the-
actually. Like if you're taking this and this, and you're saying take this and this, take you basically average.
Oh, okay.
That's what you're doing. You just figured out the method file, so what we're doing.
Is there a way to get a perfect answer using this method?
Unless it's a line that we're trying to count in the area. You just need to come in the area. Okay, so we are, get those terms down, okay? Yeah, we'll go over that today. Okay. Okay, but that's not what LRAM means. Or RRAM means. Okay, RRAM is a method. What is the name of the method? This is term identity. It's like a little literacy lesson here. RRAM, I don't want you to describe what you're going to do. I want you to tell me what RRAM means. Okay, what is a term? What does MRAM mean? Exactly. Okay. So what do those terms mean? We need that literacy component so that when we see these on tests, we know, oh, that is this particular method because the name of the method tells you what to do. Okay? I'll adjust that. Correct. That's it. Awesome, awesome, awesome. So those are actual terms, right? These aren't.
Yeah, we got them on this side.
Okay, but that's only one word. This is 4 letters. So RRAM stands for what? Doesn't just stand for right.
That's all I need.
Huh?
That's all I need, and I'll like remember what it is. So.
What does it stand for? Okay, so tell me what this stands for. Because the College Board will use this, it will use that term. And so you have to associate that term with the process. Okay, so what is R, and they won't use RRAM. They won't say do an RRAM. They'll say do it. They'll actually use the phrase. Okay, so what are those? I agree. So nobody will ever ask you to do a RAM. They'll ask you to do a blank.
What is the acronyms
So what does that mean?
I think that was describing wasn't okay. Oh, you're doing
We'll talk, but yeah, we're right now, we're looking on page 1 in the middle.
Yeah.
Okay, awesome. Awesome, that is exactly it. Anybody want to give me what RAM stands for?
Right rectangle approximation method.
Exactly, right. That's the first R, rectangular. The second R, approximation. That's the A, method. Okay, from there you should be able to get the other two. You will never be asked to do an RRAM or LRAM, maybe in WebAssign, but on tests you'll be asked to do rectangular approximation methods. And so you have to associate that terminology with either the letter abbreviations or the picture, the visual down below. Okay. Just it's all really boiling down to calculus literacy is really what that is speaking to. Okay, so I'm going to do a quick quick circulation here, and see what you've decided about which method you would choose below. Okay, so and why? When we say justify, I agree. Give the justification there. Okay. When they say justify, they're saying, give me a reason why. Give me a compelling reason as to why this is the best choice. Okay. A sentence, maybe two if you're feeling particularly wordy. I agree with their table there. Okay, sounds good.
Yeah, I mean, I haven't done another version back yet, and I just forgot to print out those today.
You should be able to go to the asterisk and go into purchase tax.
Okay,
Okay. You should get, you should pay for it.
okay.
Just take your purchase tax.
I think we're sure we're this one away.
Okay, that works too. Okay, so a quick circulation. People are choosing which one? Which one are we choosing here as I walk around and see your desks? The middle one? Give me a compelling reason. Justify that.
Because it's only got a little amount that's missing inside, and it also has a little amount that goes over, which kind of makes up for it. So then you end up with almost fitting the line if you move the stuff that's over underneath it.
Yeah, so Noah's saying, hey, this little bit's outside and it can go into that little void right there, that space, and we can start filling in the gaps, so to speak. And so that way we don't have everything outside or everything inside. Okay? And so on, all the way through all of those rectangles. So today's focus then is using one of these three methods to approximate physical values in practical applications. So for instance, you have two things you're going to work through. This first one is taking, in I think probably a notability, you can see this a little bit better than the screen is showing here. But we're taking a nose cone of a rocket and we're estimating the volume of that nose cone. And we're going to use this approximation method to do that. So this nose cone is kind of, well, it's not really a pyramid because it doesn't come to a point, but it is the edge of this nose cone here. That profile is basically the function y equals the square root of x. So if that is the profile of the nose cone and we graph that on a flat page, if we slice through that, then we can approximate the interior of that nose cone. Whoops. We can approximate the interior of that nose cone by drawing rectangles up to the edge of that nose cone and then spinning them around this axis. So we take that rectangle and we spin it around that axis. So if we would do that, take a rectangle and spin it around the axis, we end up with what three-dimensional shape? If we take that and end up with,
Like a bowl.
yeah, the whole
Round.
thing, the whole shape is a bowl. Did you want to say something?
Like what I was saying before, there's a bunch of cylinders.
Yeah, exactly. So if the whole thing ends up with like being like this big bowl, but if we just take one of these rectangles and spin it around, so we take this one rectangle and spin it around here, then we end up with something that looks like a thin disc or a cylinder. And so if we take a look at the properties, how do we find the volume of the cylinder? This goes back to our geometry, geometry equations. We take that rectangle, we spin it around. So here's that rectangle we've spun around.
And you can just take that.
So here's that rectangle here that we've spun around. And how do we calculate then the volume of this?
You can take the.
Pi r squared.
Can you just multiply the? If you square the.
We're just working on this three-dimensional shape right now. Pi r squared times what? The height. What is the height of this? Yeah, it's this. It's really kind of like we're doing this, right? Pi r squared times the height. Okay, it's just that we're kind of standing it upright like a wheel almost. So pi r squared times that thickness here, we can call it t. Okay, that thickness will give us that volume for that one disk. So the question is then, if before we revolve this, before we spin this around, what does the radius and the thickness, where do we find that on this graph?
Well, the radius and thickness, if you multiply that by each other, or if you just put it, that's the rectangle,
Okay, that's the rectangle. So the radius is what part of this rectangle?
the height of it.
So this radius becomes that function value. So that radius is right here. That becomes that function value. And what about this thickness here?
It's the width of the.
Yep, exactly. That becomes this right here, the thickness. Okay. So we can get these physical quantities, radius and thickness. We can get those physical quantities from the graph, and then we can go with this. And these, what sort of approximation method is this? As I have it sketched out here.
Oh, right.
I disagree.
No, left hand.
It's a left approximation. The left corner is touching the function. Okay. So there's one application so that we can take an approximation method and actually get a physical volume of something. And this actually ties into a project we're going to do after the AP exam. The next practical application that we see a lot of in free response questions is actually taking a table of data, and instead of having a function, we now have a table of data. So if we look at this 6, we have 6 comma 1.4, 8 comma 2.7, 10 comma 3.7, 12 4.1. So we have this table of data here, and from this table we're going to develop an approximation method and choose whatever one you want to use to determine the area underneath this curve. And so for this particular data, this is the snowfall rate in Boston over the last 24 hours. So we went out at snowing at all, and at 4 a.m. At 6 a.m. the snowfall rate was 1.4 inches per hour, etc. So we wrote down we wrote down and we graphed those snowfall rates, and then if you go ahead and find the area underneath here, that's going to give you some sort of physical significance to what happened in Boston over the last 24 hours. Okay, so those are your two application problems that I want you to work on. And then after your table gets done with those, or you get done with those, then you can go ahead and start the web assignment. Okay? So why don't you go ahead and start working on that with a couple other individuals, and I'll catch up to you in a sec. So going back to the first example, the answer to the first example is right there. After you worked that, you should be getting that volume. And the answer to the second example for the snowfall in Boston is a little bit off. They really didn't get that much snow, but that's the amount of snow that would have fallen if the snowfall rate was as indicated by the data.